Hi there, and welcome to math class. In this math lesson, we are going to be looking at multiplication comparisons. And if you have the math toolkit for this course, there are two pieces in there that look like these. They're item 13. So you should have two of those that you just cut out. I would not paste them down yet because we're not sure exactly where they need to go, but just have those ready to work with. And I'm going to actually move one of mine over out of the way. I'll just put it on the next page for a minute so that I can work with just one at a time. So let's first of all give our page a title like we always do. And this one is called Multiplication Comparisons. There are no flashcards. Multiplication comparisons. Okay. So we are going to be working with multiplication, and we're going to be comparing different problems that relate to each other. If your children are working on these in early elementary school, they call them fact families. Okay, so if your kids are coming home with fact families, this is what they're preparing them to do. So I chose a jigsaw piece because I think that's a very good way to understand that these pieces are related. They're fixed together in a family. They have a relationship within a family of math facts. So to get started, I want to first of all have you write a question so that you know the type of thing I'm leading to. And if you need to stop your video, that's okay. You can do that. There are actually two questions. What number is 7 times as many as 3? And you may be thinking, I know the answer to that without going through anything. I don't need to do anything to know the answer to that. And that's great. If that is the case, that's wonderful. But what I'm getting at here is more of a thinking skill. I know the answer, and you probably know the answer. We'll just say it. It's 21. But there is a very good thinking strategy behind this question, and that thinking strategy will help you get to some algebra. Okay? All right, the first thing I want to show you is, let me think here. I want to set this up as an algebraic expression. Okay? So this is saying what number is. And the word is an equal sign. So instead of saying what number, instead of writing that out longhand, I'm going to use what's called a variable to take the place of this phrase, what number. I'm going to use an n because number starts with n. So what number is 7 times 3? That's an algebraic expression because it has the variable, it has the unknown number. So help me with this question. What number is 3 times as many as 7? So let's see if we can translate this one into algebra. Here's the word is. That's my equal sign. What number is going to be my variable? So number is 3 times as many as 7. So that is a different algebraic expression. 3 times 7 is 21. 7 times 3 is 21. So in both of these expressions, these equations, n, the value of n, is 21. And let me show you how I know that. Let's start with this first one. Instead of n, I'm going to put the 21. 21 equals 7 times 3. 21 equals 3 times 7. So in both of those situations, 21 makes a true equation. Okay? So 21 fits in both equations. So let's take a closer look at our equations. Let's look at the first one. N equals 7 times 3. 7 times as many as 3. And see what that looks like if I break it down, if I stretch it out, as opposed to 3 times 7. Okay? So the first one is saying 7 times 3. So what they want me to think through, I'm going to use x's. You can use anything you want, little stick figures or whatever. But I'm going to express this equation in graphic form. I'm going to draw it out for you. So here's what it looks like, and I'm going to change colors so you can see exactly what I'm doing here. So let's draw 3 x's. Okay, that is one set of 3. Alright, let's draw another set of x's. There are 2 sets of 3. And we know that at 2 sets of 3 we have 6. One set of 3 we have just 3 x's. So 3 sets of 3, that's 3 sets of 3, is 9 x's. I can count them. 4 sets of 3 makes a total of 12, an even dozen. 5 sets of 3 makes a total of 15. 6 sets of 3, total of 18. And finally 7 sets of 3 is 21. Okay. So what we can say, this is a vocabulary word, but I did not do a flashcard. These x's, these layers, are called iterations. Iterations. So we have 7 iterations of 3. And I'm going to leave that alone. Thought I could turn it around, but we have 7 iterations of 3. And that gives us a final answer of 21. Okay, let's look at this equation the other way and see how it differs. So let's turn it around so that we have 3 iterations of 7. And let's take a look at what that looks like graphically. So I'm going to say the first iteration will have 7 pieces. So there's one group of 7, and that is 7. The second iteration would bring me up to 14. And the third iteration, 3 iterations of 7 equal 21. So here are the iterations. That's a good word to impress your friends with. Most people are not going to know what that means unless they've studied math. 3 iterations of 7. And you may be thinking, okay, so what's the point? I understand that 7 times 3 is 21. What I want you to understand, I want you to understand 2 things. First of all, why is it 21? And secondly, it doesn't matter if I write it as 7 times 3 or as 3 times 7. The product does not change. The 21 is going to stay the same. So all of these fact families, or these equations, are related to each other forever. This relationship will never change. You can cut these jigsaw pieces apart and separate them, but you can always fit them back together. This concept is not going to change. Okay, let's try another example. There are actually 3 examples I want to show you. 2 of them involve these pieces, and then one is just a question that I want to ask you. So let me cut this one back out and paste it over here. And you can go ahead and paste yours down however you like them to be. It doesn't matter. As long as you're getting the concept, that is fine. So for this one, I want to ask you this question. What number is 5 times as many as 10? I'm sorry, as 2. I gave you the answer. And then I want to ask the question, what number is 2 times as many as 5? Okay. So let's use our algebra skill that we learned a few minutes ago. Find the word is. That is your equal sign. What number? I'm going to let that be an n. So my equation is going to look like this. N equals 5 times 2. And then in this equation, we have n equals 2 times 5. You are already learning to set up algebra problems. So if you are one of those many students I've seen over the years who is terrified of algebra, you're already doing it. You are writing algebra equations right now. Do not be afraid of algebra. We will get through it just like we have all these other things, and you will be just fine. Do not let that be something you're fearing and nervous about. So what is the number? 5 times 2 is 10. 2 times 5 is 10. So the number that we're looking for in both of these is a 10. 10 equals 5 times 2. That's true. And 10 also equals 2 times 5. So let's give the graphic representation of these two equations. First one I'm going to work on is 5 times 2. Second one I'm going to work on is 2 times 5. So I'm just going to write those in. They relate back to that piece at the top. They're all related forever and ever. But let's see why. Let's do the iterations and see what it looks like graphically. So this is saying 5 iterations of 2. So we have 2 x's. That's the first iteration. And we have a total of 2. Then we have 2 more. That's the second iteration of 2. And we have 4 total. We have the third iteration of 2. And that is 6 total. We have the fourth iteration of 2 is 8. And then we have the fifth iteration of 2, and that is 10, which we know it's 10. That we've already figured that out up in the top section. But this is why it's 10. The fifth iteration of 2 is equal to 10. And then to show this one in illustrated form, we have 2 iterations of 5. So we have 1, 2, 3, 4, 5. That's 1 iteration of 5. 1, 2, 3, 4, 5. That's 2 iterations of 5. And there is our 10. So either way we look at this picture, whether I'm looking at this picture or this picture, this kind of relates back to those area models. There are 10 x's in each of those pictures. It's just a matter of how we got to 10. There are 2 ways that we can get 10 x's. 2 points that I want you to, well, really 1 point and 1 piece of information. If you have children who are studying these, this can help them. If they're not understanding these kinds of concepts, have them to draw them out. Pictures are awesome tools to teach. The second thing that I want you to remember, and this is the key thing, is that with multiplication, the order of the factors does not matter. 1 times 10 is the same as 10 times 1. You can reverse the order in multiplication and addition, by the way, because you're building up those quantities. Okay, one more example that does not involve a jigsaw puzzle. What if it said to explain 5 times 10 is 50? So what if they gave you the completed equation and asked you to explain what it means? I want to put this in 4 different ways for you. Okay. First way you could say this is that 5 times 10, there's the equal sign, the word is 50. Or another way to say that is that 5 iterations of 10 and because iterations is plural, I'm going to say are 50. linking verbs are equal signs. So that's one way you can say it. 5 times 10 is 50, which is the same thing as saying 5 iterations of 10 are 50. But there's another way. What if I said 10 times 5 is 50? That's true. So if that's true, 10 iterations of 5 are 50. So those are some ways to explain that equation. Now when we do the actual worksheets for this page, in the workbook, you'll get to practice these skills a little more. So if you're feeling a little rough with them, don't worry, we're going to practice those very soon. And I will see you in that video very soon. I hope you have a great day today. Bye-bye.